Welcome to our maths class on rates and ratios. And today I want us to look at dividing a quantity in a given ratio. First, I want you to think of a ratio because ratio is connected closely to a fraction. When we say like 1 to 2 is like 1 over 2, there's no difference. So we are saying let us think of it. Let us look at ratio because it is related to fraction. So I want us to look at it this way. If you have a ratio, maybe 1 to 4, 2 to something, let us look at each part, each number in terms of parts. Such that if we have the following ratio, 1 to 4, let us look at it in terms of parts. So that the first part is 1. The second part, there are how many parts? There are 4 parts. So we have the first part with a single part and the second part with 4 parts. And the total number of parts is the sum of the ratio, which is 5 parts. So a ratio can be easily understood in form of parts. I want you to look at this situation. If we look at, let us look at cordial juice. When we look at a drink which is simply made up of some cordial and part of water, cordial and water, and we say that one part we have, if it's mixed, if drink is actually made up of cordial and water in the ratio of cordial to water at 1 to 4, then it means that 1 part of cordial and 4 parts of water. So we find that the total parts when you have cordial and water, it gives us a total of 5 parts. So here, in simple terms, it's simply telling us that 1 single part of cordial mixed with the 4 parts of water forms a complete drink. That is what this ratio is trying to tell us. So if you want to find the fraction of cordial in a drink, it will be taken as it will be given as number of cordial parts over what we call the total number of parts. So for us to get the fraction or the fraction of cordial in a drink, we shall take, according to the ratio we have 1 to 4, we shall take number of cordial parts, which is 1, over total number of parts, and total number of parts is what? 5. So the fraction becomes 1 over 5. 1 over 5. What if we are to get the fraction of water? Fraction of water in the drink. Now, similarly, we want to find out the fraction parts of water in a drink. And here, it will be given by number of water parts over total number of the parts, which number of water parts is 4, and total number is what? Is 5. So fraction part of water in a drink gives us 4/5. Let us also look at this. Consider this is just as you discuss. If you have $120 and you wish to share it between several people, and I want us to take several situations, amount is $120. Let us look at the following various situations. 1, so we are looking at two situations of $120, and the first situation, 2 people, Jack and Pippa, share in the ratio in the ratio 1:1. As I told you earlier on, the order matters very much, and the order is Jack to Pippa. The order remains, so we are sharing 1:1. No? That means Jack gets 1 part of the share. Pippa gets also 1 part of the share. The 2 of them forms how many parts? 2 parts. That simply means for us to get what Jack will get, for Jack, it will be 1, that is his part, over the total. And then we multiply by, so you'll get a half of the amount. That's the fraction part, a half of the amount, which is $120. So this off is replaced by a multiplication sign. By 2 is 1, by 2 is 6 and 0. So this is equivalent to 60 shillings. Or $60, sorry. You find this one is equivalent to sum of money, $60. Because it was 1 part for Jack, 1 part for Pippa, so Pippa also gets a half because it is 1 part over the total of $120, you'll get $60. Different situation over the same amount shared. And this time round, 2 people are going to share this, Jess and Teresa. Two people, Jess and Teresa, sharing the same amount of $120 in the ratio 2:3. For fraction part that Jess takes will be, for Jess part, will be 2 parts over the total parts, which is 5, of the total amount, which is $120. This is the same as 2/5 multiplied by 120, by 5 is 1, by 5 is 2, the 220 by 5 gives us 4, and then 24 multiplied by 2 giving us $48. Sometimes you can choose to use unitary, as we shall illustrate in the next the coming examples. So you can use this and your fraction, and you can also do it using unitary method. So generally, given any ratio, we are able to share out the amount, we are able to share out quantities as long as there is a ratio, given that the first part will be representing a part of what one will take, and so on. Let us look at, supposing we have 3 people sharing, or 4, and so on. Each ratio will represent part of each individual. So let us look at 3 people. Matt, Leos, and they are sharing in the ratio 3 to 5 to 7. Simple as that. The way the order of the ratio is will be proportional, and it will be proportional to the way the flow of names is. That is 3 to 5 to 7 and Matt to Leos to Kara. They should be representing each other. So in this case here, we know that Matt takes 3 parts, Leos takes 5 parts, and Kara takes 7 parts of the total parts. And the total parts is what? 3 plus 5 plus 8 plus 7, which is 15. So just look at Matt. We'll take 5 parts of the total. Total parts is 15 parts. That's the total parts of $120. So this is the same as highest. We look for highest common factors, and if not that, we look for factors that can simplify both. By 3 is 1, by 3 is 5, by 5 is 1, by 5 is 24. Therefore, Matt will take home $24. Which means 3, the ratio of 3 represents 24. What if we are looking at this other person, Leos? So we are through with Matt, total of $24. So Leos, how many parts is Leos going to take of the total? 5 parts. What is the total number of parts? 15. What is the total amount being shared? $120. By 5, 1, by 5, 3. By 3, 1, by 3 here, 4, 0. Leos carries home $40. And the remaining, which can be done either by calculation or can be done by subtraction. Choose what you wish, We are doing ratio, so let us maintain the ratio method. Kara will take 7 parts of the total, which is 15, multiplied by $120. Now here, very interesting is that 7 is not, 15 is not divisible by 7, so we are looking at the other side. By 5 is 3, by 5 here is 24. By 3 is 1, by 3 is 8. 7 multiplied by 8 is 56. So we shall say Kara will take home $56. If you didn't want to do it this way, you would take $120, subtract the first, the sum, that is 24 plus 40, which is 64. When you subtract that, this is 6, this is 5. So it will come to $56. We've been able to find the amount of dollars each one will take in case the sharing ratio is 3 to 5 to 7 and the total amount is $120. So that is the approach of sharing out. So what are the major points we need to observe? The major points we need to observe when handling the idea of dividing a quantity by a given ratio, we need to observe the following. First, think of a ratio in terms of parts. Think of a ratio in terms of parts. Now, this time round I told you we shall look at it. We shall apply the unitary method to divide a given quantity. Using unitary method to divide a quantity in a given ratio, we shall use that. Now, this one involves finding the total number of parts in a ratio. It also involves finding what one part represents. So one part, unitary simply is for one individual part. And then finding the number of parts required or the value of the parts required in the ratio. So I want us to take, for example, can we share out $20 in the ratio of 2 to 3? If we are to share $20 in the ratio 2 to 3, we are saying here, we apply what we've just said, that first think of this 2 to 3 as parts. So we have the first side, we have how many parts? 2 parts. And the second side, we have got 3 parts. And the total parts is what? 2 plus 3. So the question is, we need to get the value of the number of parts required. So the very important thing is the unit in the unitary method is to find out what one part will represent. So we need to find the value of one part in the unitary method, and we need to also know, we need to find the value of one part, and we are also supposed to know the total number of parts. What is the one part is simply 1. So the value will be 1 of whatever. Total number of parts is, in this case, it's 5. Take note, we have not gone for the required parts. We have only gone for one part. That is unitary approach. So that we say, for us to get the value of one part, it is 1 over the total value, which is 1 over 5 of the amount required, which is $20. And this one will give us $4. You see? So, one part of the 5 parts is equivalent to $4. What was required? What was required was us to tell what would be the amount if we share $20 in the ratio 2 to 3. So can we look for the 2, then we look for the 3. If one part is $4, what is 2 parts? So the point about unitary approach is very easy because it is simple. If one part, $4, how about 2 parts? It will be 4 multiplied by 2 parts, which will give us $8. How about 3 parts? It will be 4 multiplied by 3. $12. So we are saying under unitary method, which is a very easy method to approach ratios when you are dividing a quantity in a given ratio, is so easy because the moment we have the value of one part, we can easily get all the other parts. If we choose not to use this method, we can use fractions to divide a quantity in a given ratio. Using fractions to divide a quantity in a given ratio. Now, what is important here is to know the fraction of the amount required. The fraction of the amount required. And this is given by number in the ratio of a total number of parts. For us to find the number of amount required, we shall look at number in the ratio over total number of parts required. We can refer to what we just went through and see what are we trying to say here. We were trying to allocate what it will represent if we share out total of $20 in the ratio 2 to 3. So we are saying a fraction of the amount required. For now, we are starting with the first part. Fraction of the amount required is equals to number in the ratio. What is the number in the ratio of the first number? It is what? 2 over the total number of parts, which is what? 5. So the fraction we have is, we are looking for the fraction of the amount. It is 2 over 5. But when we say of the amount, we write there of the amount, and the amount is $20. Replace of with a multiplication sign. When you multiply this, you'll find that by 5 is 1, by 5 is 4, you get $8. So this one has just gone straight because we are asked the fraction amount. So the fraction amount is 2 over 5, and the amount itself is now fraction of the total amount, which is going to give us what we have is what? Is 8. So already we have seen that for us to solve such questions that involve sharing amount in a given ratio, we have already seen that there are 2 approaches. We either approach it in a unitary manner or using unitary method, or we shall just use the fraction method by finding the fraction of the amount and we move ahead to find the amount each value will represent. There is a need for us to know how to find the total quantity from a given ratio. How do we find the total quantity from a given ratio? Now here, we are going to use the concept of parts. There are 2 areas. We are going to use the concept of parts and the unitary method to find the total number of parts, and therefore the value of each part, which hence will give us the total. If we don't use that, we can go in for a fraction. And here we shall be required to find the value of each quantity, and then we can add up to find the total in the quantity. Now, so generally, when we have 2 approaches in solving a question, we should not have a problem. It is a matter of choosing which one is the simpler or which method would you prefer. So let us look at the following questions now, and we are going to approach them from both the unitary method and the fraction method. So we want to say that if you are solving questions about the issue of dividing a quantity in a given ratio, we need to have both the 2 methods within our fingertips. So let us look at the following questions. Divide 54 meters, that is the units, in the ratio 4 to 5. In other words, they are asking us what will be the parts formed by the first area, and how many, or what is the length of parts formed by the second area. So to approach this question, we shall start by using the first method. We call it the unitary method. For us to approach this method using unitary method, we shall ask ourselves the first question. What is the total parts. And the total parts is what? Total parts, total number of parts in this ratio is the sum of the numbers, which is 4 and 5, which gives us 9. That's the total number of parts. Now, if we want to use unitary method, it means, can we reduce the 9 parts to be 1? Can we reduce the 9 parts to be 1? Why are we saying that? Because the 9 parts is the whole parts, and the whole parts represents how many, what quantity? 54 meters. So we want to say this. You will agree with me that 9 parts is formed by a total of 54 meters. How about 1 part? 1 part is gotten by dividing (9) by 9 to get 1 part. Therefore, the same will apply. You take the 54 and divide by 9. And when you do that, you'll end up finding, it is what? 6. So then now, here we are. Unitary method. 1 part, 6 meters. 9 parts, how many? 54 meters. And then somebody will ask you, what about the parts we have here? Is there a question about this? The number of parts, as long as you have 1 part of it. The rest of the part you only multiply by the number of parts. So 1 part, if you check here, 1 part is 6 meters. So how about 4 parts, and how about 5 parts? So for 4 parts, if I take this, multiply by 4, then I'm looking for what? 4 parts, which forms my first side. And then this one will also multiply by 4 parts, and it will give us 6 multiplied by 4, which is 24 meters. So if you divide 54 in the ratio of 4 to 5, the one who will be taking the first part of 4 of the total units will take home 24 meters. For the other ones, you can just subtract. What is remaining? It's 30. But now our approach is to see how do we get now the other one. Let us see how the first part can be calculated using the fraction method. But I've said if the first part is 24, the second part, because there were only 2 parts, will take the 5 parts will be 54 minus 24, which is that. It can still be calculated, as we shall see. So I want us to look at fraction method. These are about ratio. We are given a ratio of 4 to 5. The first part is simply represented by 4 over the totals, which is 4 over. So we are looking at, let me explain here. We need to find the fraction of the first part. Fraction of the first part is 4. Total number of parts is what? 9. So we are talking of the first part being represented by 4/9 of 54 meters, which is the same as 4/9 times 54 by 4 is 1, by 4 here is 6. 6 times 4 is 24. So it is still giving us the same answer. Unitary method, fraction method. If you were to look for the second part, now I'm going to do second part using fraction and not unitary. For the second part, the fraction would be the value of the second, which is 5, over total, which is 9, multiplied by the total number of the total amount, which is equivalent to 54, by 9, 1 by 9, 6, 6 times 5, it is 30 meters. So we'll always get the same answer. So we should be able to carry out the issue of sharing out certain length in a given ratio using both methods. Now, I want us to look at now a situation where we have got about 3 terms in the ratio. Not 1 or 2, but this time 3 terms in the ratio. Dividing a quantity in a ratio with 3 terms. Yeah, we have the question: divide $300 in the ratio 2 to 1 to 3. So we have several approaches. The unitary method will apply always, and then we move on. So first, in this question, let us calculate find the total number of parts, and the total number of parts here is 6. And if it is 6, it is equivalent to the total amount, which is 300. Therefore, one part will require us to divide the 6 parts by 6. You'll get one part is equals to $300 by 6, which will give us 50. Therefore, we say that one part is equivalent to how many dollars? $50. But we are looking for how many parts? 2 parts. 2 parts will be $2 times $50, which is $100. 3 parts will be 3 times 50, which is $150. 4 parts, even if we don't have it here. 4 parts, you'll take 4 multiplied by what? 4 multiplied by the number of parts. So, if you can see, unitary method, the moment you have found one part, you can get as many parts as possible, but don't go beyond the total number of parts, right? So 4 parts will be 4 multiplied by the amount of one part, which is 50, gives us $200. We move on. If it was 5 parts, and finally 6 parts is the whole, which is 300. So I'm not going to go into that. Then let us now look at our question and see. 2 parts, you just look where 2 parts are. 2 parts is equivalent to 100. 1 part is equivalent to 50. 3 parts is equivalent to 150. So we are saying the moment you apply unitary method, you are able to get any part of a ratio given that you know the value of 1 part. So we are able to find that. So can we now answer this question? What is the amount if we share the $300 in the ratio 2 to 1 to 3? So it will be how many dollars? The proportionally 2 is here will be $100. And then 1 will receive $50 and 3 will receive $150. That is how they will share out. That's the amount each one will take home. If we were to approach this now using the fraction method, the same question. Now, fraction method, we normally go straight to finding the amount for each ratio. So, fraction of the first part is given by the number there, which is 2, over the total number of parts, which is this case 6, if I'm not wrong, of the total amount, which is $300. Replace off with a multiplication sign. It will be 2 over 6 multiplied by 300 by 2, 1 by 2, 3 by 3, 1 by 3, 100. So this gives us total of $100. What were we looking for? We were looking for 2 over 6 of the total amount, and that is what is giving us, directly giving us the amount assigned to the first ratio. That is fraction method. Same applies second part. Fraction, we have it will be 1 over 6 of 300, which is 1 over 6 multiplied by 300 by 6, 1 by 650. What you get is a total of $50. So we have used fraction to get the second one. And the last one, hope you are writing down those answers so that we can easily allocate what we have. The last one is the number is 3 over the total number of units of $300. 3 over 6 is the same as a half times 300. Half of 300 is 150. So we can conclude and say that if $300 is divided in the ratio 2 to 1 to 3, then the amount received is $100, $50, and what? $150. That is the fraction approach. Now let us now look at the finding a total quantity from a given ratio. Finding a total quantity from a given ratio. This is an application question which we can even formulate our own in this classroom. To say the ratio of boys to girls in a school is 2 to 3. That is the ratio of boys to girls. If there are 246 boys at the school, how many students attend this school? You see, we want to find the total quantity from a given ratio. We shall apply unitary method. We shall also look at the fraction method. This is very, very necessary. So let us first approach this question using unitary method. Unitary methods. Now, how many boys are there? 246. How many girls are there? We don't know. What is the ratio of B for boys and G for girls. So what is the ratio of boys to girls? And we've been given that the ratio of boys to girls, it's boys to girls, not girls to boys to girls is. So I expect girls to be more than boys, because boys is 2, girls is 3. So we start by first finding what units does 246 represent. We know that here, total parts is what? 5. How many parts does boys represent? You will agree with me that boys represent 2 parts of the total. 2 parts of the total. Total parts, 5. Parts of the boys, 2. And what is the amount of boys? $246. So we are saying this. 2 parts is equivalent to 246. How about 1 part? That is the approach I want us to bring. So, 2 parts is 246. How about 1 part? 1 part, you will divide this side by 2. You get 1 part is equals to, divide this one by 2. You will get 123. The question is asking how many students attend school. So they are asking for everybody, which is equivalent to 5 parts. So you take 1 multiply by 5, you get 5 here. So 5 parts is equivalent to 123 multiplied by 5. And when you do that, you'll get 615 students. 615 students. If they had asked for the number of girls, we shall take 615 minus 243, or using the unitary method, because girls is 3 parts, then take 3 parts, multiply by 123. But the question we should answer is, how many attend the school? And you have said 5 parts attend school. And what does 5 parts represent? It is 123 times 5, which is 615 students. How about if we were to approach this using what we call fraction method? Because we already have the ratio of boys to girls, which is 2 to 3, and boys 246. Fraction part tells us that the fraction of boys is 2 over total, which is 5, which is equivalent to 246, right? Do you agree with that? You first find the fraction of boys. If they are looking for the fraction of girls, we would now go in for girls, but they are asking us for the total. So, what happens? We want to find the total, those who attend the school. So here, as we can all see, we want the ratio of boys to girls. Boys to girls is 2 to 3. That's what we know. Let me give it a clear approach. I want us to look at 3 ways. This is about the fraction. A fraction of 2/5 is equivalent to this. That's a fraction. But when you talk about 5, the whole of it, not girls alone, the whole of it, we will be talking about 5/5. That means the whole of it. So if the fraction of boys is this, what is the fraction of the whole of them? It is 5/5. And you realize that if I want to, what happens if I want to get 5/5 here? Take this. We want to use what we call equivalent fraction or equivalent ratio. 2/5 is this. How about 5/5? So you realize that here, the denominator is shared. We are looking at 5/5. The denominator is shared. So we are not so much interested in the denominator. 2 is this and 5 is what? That's the question here. So you'll find that this one will be 5/5 multiplied by 246 divided by 2/5, which is the same as multiplied by 5/2. Can you see that very clearly? We have multiplied by the reciprocal because we are saying 2/5 is equivalent to 246. How about 5/5? 5/5 will be 5/5 multiplied by 246 divided by 2/5, which is times 5/2. By 5, 1 by 5, 1 by 2, 1 by 2, 123. So it becomes 615 when you multiply 123 times 5. You get this is number of students. So it is easier when you also use the fraction, as long as you know the fraction of boys, then the fraction of the whole group is 5/5. If we had been asked for girls, look here. If we had been asked for girls, we would say if 2/5 is 246, what number would 3/5 represent? This one is 3/5, which is for girls, multiplied by 246, which is over 1, divided by 2/5. When you are dividing numbers, the fraction is the same as multiplying by its reciprocal. Therefore, this one will change, let me write it down, and become 5/2. So it will be 3/5 multiplied by 246/1 multiplied by 5/2. By 5, 1 by 5, 1 by 2, 1 by 2, 123. So what is the number of girls? 3 times 3 is 9, 3 times 2 is 6, and 3 times 1 is 3. Number of girls in the school is 369. The last approach is the approach of equivalent ratio method. We should all have these methods. Equivalent ratio method. Take note of this, very easy. Take note of this. Two to 3 is our ratio. So what happens in our ratio here? Two to 3 is our ratio. Can we find equivalent ratio which gives us, take note of this very clearly, equivalent ratio, let me write at the center and use a red pen to illustrate. 2 to 3 is equivalent to boys, and boys is 246 to dash. Look at that. 2 to 3 is equivalent to 246 to dash. The question now arises, what happened to 2? What happened to 2 to give us 246? It was multiplied by 123. Therefore, take 3 and multiply by 123. If you multiply this, you will get 369. So the ratio of boys to girls is 2 to 3, which is equivalent to 246, which is the true number of boys, to 369, which in this case is the true number of girls. Then the question that follows is, what is the total number? And total number here is number of boys added to number of girls, which is what? 246 plus 369. When you add that, 6 plus 9 is 5, carry 1. That's 15, carry 1. This 4 and 6 gives us 10 plus 1 is 11, carry 1. 1 plus 2 is 3, 3 plus 3 is 6. Total population of students in school is 615. 615. So when you look at all that we've gone through, it does not matter the approach we went through. We have looked at equivalent ratios. We have looked at fractions. We have looked at unitary method of approaching these ratios, but they are all giving us the same answer. So as we conclude this lesson, we should be able to find the total quantity from any given ratio. We should always be able to do that. That is it for now. When we come back, we shall be looking at what we call scale drawing. Thank you.